Well, howdy, physics sleuths and inquisitive souls. Welcome again to Dynamic Gravity. So, in this episode, we're going to do a little bit of digging into the virtual photon again. And you notice I spend a lot of my time and some amount of videos working on virtual photons, trying to crack the mystery, because we really don't know anything about these things. They're kind of just mathematical tricks that have been used, and you know they make the system make sense. The math works out with it, so we suspect they exist, and they kind of have to, because there has to be some sort of carrier particle carrying the force of the electromagnetic spectrum and hence gravity, if I'm correct, and I am gravity, to do that. So if you are new here and you have not yet read my paper on how gravity works and everything, I encourage you to do that now. You should. Do yourself a favor. It's in the description of all my videos. I think you'll find it quite enlightening. It's a summation of many years of work. So let's dig into this. And we gotta get a breakthrough on this somehow, sooner or later, because this is the game right here. According to dynamic gravity, the virtual photon is the key to everything. It carries gravity, and if we can find a way to figure out what the hell it is, and hence manipulate it, then now the doors are opened up to us to be able to manipulate gravity, and now to travel among the stars and become gods of the universe, so to speak. So, let's see if we can't do a little justice today. Here is just a generic explanation of photons, right? And here is what kind of led me to make this video. Not too long ago, on my previous videos, I realized that there are no photons that are shorter wavelength than a gamma ray. And I looked into why that is. And the reason why that is because matter is energy. It really is. You know, this is the way you have to think of matter if you want to understand the universe. It's not an actual thing that's there. It's actually energy that's consolidated at a specific point in time. And if you have the wavelength of a photon get shorter than that of a gamma ray, then now you are officially at the wavelength of an electron. And it essentially just becomes an electron. That's why there are no wavelengths higher than a gamma ray, because if it goes any higher than a gamma ray, you officially have an electron. That's what it is. That's how they're made. Crazy, right? And this brings up a whole lot of weirdness, because if this is true, which appears to be, then that means that all photons are essentially electrons. They're just spaced out in time. And that's just weird. It's insane to think about. So I asked myself the question, all right, well, what happens if we go lowest, the lowest photon we know of? And according to this and many other diagrams, that the lowest they'll go is a radio wave, right? And this is not, spoiler alert, this is not the lowest that it can go. And you can see the temperatures here, which is very interesting. They have 1K around a microwave, which is conveniently around where the microwave CMB is for black body radiation. And then they have the frequency chart, right? And so you see when it gets to a radio wave, the frequency is about 10 to the fourth, like 1,000 hertz, roughly, right? Which is, you know, wavelength in meters, that's like 1,000 meters. So it looks like, according to this graph, I don't know if this is exactly accurate or not, but I'm sure it's close enough to point us the right direction. So there is a lower wavelength than the radio waves. There are extremely low frequency, is what they're called. And this goes from about 3 hertz to 30 hertz. So it's very, very low. They do say here that the ultra low frequency is actually lower. But when we look into it, I don't know if this is just some weird thing because of how radio bandwidths are set up or something, but they actually go in the opposite direction. They're like here 100 hertz to 1 megahertz, the scale here is like 1,000 to 100 kilometers is the wavelength of a photon. But when we go back to extremely low, we see here the wavelength is actually 100,000 kilometers to 10,000 kilometers. So this is actually much lower. So I don't know. Wikipedia is not perfect. They do have errors that you're going to have to sort through if you're going to use them as a source of information like I do for so much of my work. It is what it is, man. You got to take it for what it is. Nothing's ever 100% set in stone, but I hope it will set you in the right direction to, finish out the rabbit hole that you're on and to get through it all. So I want you to notice something. 100,000 kilometers, right? And that would be about 3 hertz, okay? And I know this because I did the math. You shouldn't have to. It's pretty obvious if you think about it. 1 hertz would mean that the photon will oscillate up and down once in 1 second. And in 1 second, light will travel 300,000 kilometers per second. So 300,000 kilometers per second. So 300,000 kilometers would be 1 hertz, right? And I don't know if there's ever been a photon that's been measured that's been lower than that. It might elude our detection techniques right now that we have, that antennas can do or whatnot. But I believe that just like there's a limit in the higher end of photons with the gamma rays, or if it goes beyond that, now it officially becomes matter in the form of an electron. I believe that there's also a lower limit too. And if you get below 1 hertz and you start going into decimals of a hertz, this too is the lower limit of what a photon can be before it is officially something else and behaves differently than what we would expect it to. Like I say, there's a huge difference in how electrons behave versus gamma rays. But if you look at that, the wavelength of the spectrum there is not that big. It's very small. So it's like quantum mechanics keeps popping back in with the one golden rule that it was founded upon, and that you cannot have continuous amounts of energy or matter or anything really. Everything has to be quantized in discrete levels. And we don't know why these levels are. I mean, there's obviously a reason for it, but this eludes our physics or quantum mechanics at this time. But this is the next great revolution that's going to have to take place in our science if we really want to conquer gravity. We have to understand why it is that photons behave differently at different wavelengths. And if they get so high, they become an electron. And if they get so low, it appears they become a virtual photon. Not a real photon, but a virtual photon. And that is the carrier particle for gravity. So let's take a look here. Here is, this is just some random page, whatever, but this is an important formula we're going to have to look at. This V is frequency, or I guess you could argue hertz. This is the wavelength. So this is how long the photon is, right? And this is, of course, the speed of light. which is the speed at which photons travel. So if we have a photon that is actually longer, the wavelength is longer than the speed of light travels in 1 second, and the hertz is no longer above 1, but now it's going to be a decimal going lower. I believe this is the cutoff where we can officially say it's pretty much a virtual photon at this point, and it's going to behave differently. It's going to somehow, I've done other videos on this to how I think it happens, but I'm by no means the world's most leading expert on virtual photons. I'm trying to get there, though. I'm trying to understand them as best as everyone else, and then figure out what's actually going on, how it would have to work if dynamic gravity were true. So I believe, if you have a atom with a proton and electron, and there's energy going into it, but not enough energy to push it up fast enough so that it can create a real photon, but instead it goes so slow and moves so slow, doesn't have enough energy going fast enough, but it still moves, then now you have what is constantly being released by all matter that is not at absolute zero, where it then becomes an Einstein-Bose condensate, and it kind of loses the ability to create virtual photons and interact with itself and hold itself together. And all the matter just becomes like some form of plasma that kind of loses all its properties until you heat it back up again, then it reverts back into the molecule or matter that you were dealing with before. So there is evidence to support this theory that I have, and this is just a theory that, once again, nobody really knows what virtual photons are about yet. We're working on it, though. What we need to know for this video is that the speed of light is 3, times 10 to the 8th meters per second. And if we get a wavelength that's longer than 3 times 8 to the meters, you're going to now have decimals of hertz instead of a full integer of a hertz. It's going to be decimals. And I think that's where funny things happen. So let's see if we can't do a little math and see what the math tells us. This right here is just some article that goes off into transferring like photonic energy into force, but they do it through like intensity and area of the affected intensity, and this formula does not really help us out much. So let's just move on. This is just some more bullshit stuff, but they show their math. They show the formulas which we want to play around with, right? And this is a really good one, it looks like, because force exerted by a light beam. So this formula is saying it can calculate how much force photons in a light beam will generate on something. This N is number of photons absorbed right here. And here is the generic formula for that, which is going to turn into, what is that, power of the beam in watts times the wavelength, which is what we're messing around with right now. So let's make the power 1, right? Just to make it simple so we can see what the math is telling us, all right? So this is not going to be 10, it's going to be 1. And this, the wavelength, is we're going to have at the speed of light. So it's going to be 3 times 10 to the 8th meters is going to be the wavelength, right? And it's going to be then divided by Planck length divided by the speed of light. Well, it's funny because once we hit the speed of light, this now is going to be the same number as this bottom speed of light integer number right here, value. So these are going to cancel out and just make 1. And this is just already 1 for simplicity's sake, so it's all 1. So what we have effectively once we have a decimal of a hertz of the frequency, and the wavelength is now longer than light can travel in 1 second, this equation cancels out, and then what we're left is the opposite of Planck's constant. So instead of having Planck's constant, we're going to have Planck's constant divided by 1. Very interesting, because then that's going to be our answer for n, for a number of photons absorbed. So we take that and we times it by here, this is forming Planck's constant. So we have the inverse of Planck's constant times Planck's constant. That's just going to cancel out to equal 1. So, and then we're going to have our wavelength, which is going to be, 3 times 10 to the 8th. This is not the right numbers, but 3 times 10 to the 8th. So if you can think about it, what you really have then is now that creates the force is the inverse of the speed of light. That's kind of weird. The formula, the math doesn't break apart, like a lot of Einstein's math does. Once you, achieve the speed of light or, break that limit. So that's a little disappointing that we weren't able to break this formula with this, a theory we have. That would be a huge proof that, okay, we're on to something. Something's going on, and we're describing it pretty good. But it definitely, as this number gets larger on the bottom, the force obviously is going to go down. So this number is just only going to go down lower and lower and lower, and that's because you're transferring less and less energy from the photons per second, because the photons are actually arriving longer than periods of a second. I'm still trying to figure out what this means and how this all plays together with all of our known physics, and how to manipulate this to create anti-gravity or artificial gravity, whichever. Either would be acceptable at this point. But I just want you to think about this. This is kind of crazy. Like, most photons are like nanometers, like visible light, whatever. It's all nanometers. It's like, a millionth of a meter or something. But if we're going to be talking about virtual photons, if they are exactly what I think they are, you're going to have a single photon that's going to be longer than the distance from Earth to the moon, okay? Because Earth to the moon is about 300,000 meters. So it's about the time light travels in like 1,000 kilometers. About the time light travels in 1 second. So you're going to have a photon that's actually going to be so long that it's going to hit the moon and start transferring that energy to whatever it hits on the moon before it's even done being made and finished here on the Earth. That's insane when you think about it. And that creates conundrums. That's just weird. I mean, you could almost imagine, photons are directional. They're not omnidirectional. They don't go out at all directions. They go one direction. So it'd be like a beam just being shot out to the moon. They'd be transferring energy, but somehow, because it's negative energy or whatever, because it's longer than the typical wavelength of a photon, less than a hertz, it's going to create the opposite reaction and draw the matter towards it instead of pushing it away, I guess, as a regular photon would do with, energy momentum transfer. It's just weird. And if you could imagine, like, I personally believe that for every one real photon an atom emits from heat, whatever other photons hitting it, you have billions of virtual photons, where the energy was just being hit on this atom, but it wasn't enough to create a real photon, but it's just emitting these beams of photonic energy, of virtual photons in that form, one at a time, but in all different directions, depending on whichever direction the electron is moving when it gets dispersed of this energy. It's wild. And I got another theory that I'm actually super stoked about. I'm not ready to talk about that theory yet. I've already given you guys how I believe the universe began with the gradual universe theory, and how I believe gravity works with dynamic gravity. Well, I got another theory that's just as big as both of those. And I'm so excited because this actually vindicates that theory and adds credence and proof to that theory. And one of these days, if you're lucky, I'll tell you that theory. But it's pretty out there, so I don't know what you guys think I'm crazy just yet. But anyways, that's all I wanted to go into today, was just that simple fact to kind of give you a very generic but hopefully accurate explanation, if I'm correct, on what a virtual photon is and why they're so important and how they behave and how prevalent they are. With that, I'll see you next time. You guys have a great day. Bye.
Like, subscribe, submit.